So I just got done recording the first part to this whole series, which is the actual building of the infrastructure behind this, the whole RTMP server, or RTMP Streaming Server, saving the video, doing all of that logic. So if you've not seen that video, go check it out. But this is the second part that's like a tangentially related topic that was given to me the idea of basically or making the clip system like Twitch and YouTube and all of the streaming platforms have, and making it here. And originally I thought that was actually gonna be really easy, because I thought you could just take the last 30 seconds of a stream, shove it into a buffer, or a circular buffer or a queue or something, and then FFmpeg magic would just dump that buffer to a file when you hit a button or give it some sort of action. And apparently FFmpeg does not have the concept of a buffer of video, like I'm trying, or at least I thought it was going to. So it's taking me down the rabbit hole of some different solutions. One is not using FFmpeg, the other is using FFmpeg, and I think the solution that I'm going to go with is neither of them. But let's go over the solutions I have first to kind of show you how I've got to where I am now. So the first solution I have here is my one with Python. It is using OpenCV to take an RTMP stream, extract all the frames, and save the frame, or save each individual frame, into a queue or buffer. And that buffer is a set time that I've defined here, so 30 seconds. Then any frame beyond that is just dropped from the buffer. That way we only have a buffer of the last 30 seconds of a stream. And then when you press a key, in this case Q, it just takes all those frames, dumps it to an MP4 file, and we're golden. And this actually works. This works, honestly, pretty well. The downside is that the way OpenCV works is it takes the RTMP stream and it actually inflates every frame. Obviously, the RTMP stream itself isn't, it's not sending every single pixel of every single frame. It's, sending a mathy version of how it changes between each frame. I could be wrong on that, but the main idea is that it's not sending every pixel of every frame through the wire. So because of that, I thought you could just you could store the frames in a buffer and kind of create something with that through the intra frames and all that. But no, OpenCV actually inflates every frame. That way you do get all of the bytes and all the pixels of every frame in each frame. And so, a 1080p stream is 1080 times 1920 times 3 bytes, and that's a lot of RAM. I think like 30 seconds was like 8 gigabytes of RAM. I don't remember off the top of my head, but it was a lot. Enough to where this is not scalable whatsoever. So, while this works, it doesn't work, if it makes sense. And so, cool idea. I love making this, but I had to look at other options, which takes me to my FFmpeg solution. Now, I said FFmpeg doesn't have the circular buffer that I was thinking it did, but what it does have is what's called segments, I guess, to where you can give it, in this case I'm actually giving it the HLS stream, but you give it a stream and it basically chops up the stream into segments of equal time. And as you can see here, the files, it has like the circular buffer is in its files it creates from the segments. So each of these files, I have 10 of them, is I think 5 seconds. Yeah, it's like 5 seconds. So in theory, if I wanted a 30-second clip, I would simply just find the most recent segment that it's saved to, and then grab the 5 before that. That way you have 6 segments, smash all the segments together to a larger video, and that is your 30-second clip. And this also works okay. The only thing I don't like about this is the fact that the read, write, and creation of this. Obviously, it's not too much space because it does overwrite the files as it goes through. So there's only 10 segments, and once it writes the 9th segment, it goes back and overwrites the 0th segment and 1 and 2 and whatnot. And so I'm not entirely happy with how this just hits the disk, I guess. A solution possibly this would be to create a RAM disk or a RAM buffer. That way it's only writing files that were in RAM, so it's a little bit more efficient that way. But in the end, I think this is just still also not ideal, especially because in order to have this clip system work, this command has to be running actively for all of the streams that are going, which I don't think is right. So given both of these solutions, I think the solution we go with is the third option, which I'm hoping works. But because I'm recording the video that comes off of the cameras as they're streaming, I'm hoping that I can use this concept of grabbing the latest segment and applying it to the segments I record and grabbing the latest segment and possibly the one before it because of overlap. If you're grabbing a clip from like where it transfers, smashing those together and then using FFmpeg to grab the last 30 seconds in that FLV file. I don't know how FLV works. I'm hoping that this is okay. We'll find out. That's the goal here today, is to find out if this is possible. If it is, great. That's probably the solution I'll go with. But there's only one way to find out. So that's my task for the next little while. Turns out my theory is correct in that I can just take a currently being saved FLV video and just take a clip out of it from using FFmpeg as it's being saved. So that makes my life a lot easier for creating clips from live streams. So I have gone through and I have now made a proof of concept clipping system for this, this project, I guess. So for this project here, you can see this is, I believe it's live. I think it's live. It's hard. It's a rainy day. There's not much movement outside, so I think it's live. But you'll see is that there's this nice little clip button down here. What I can do is I can go ahead and hit clip. And because this is a very intuitive UI, it actually doesn't do anything. I didn't worry about that. I just want to make sure the backend logic works for this. But I can go to this and I can see all of the clips here. And you'll notice that, yep, there you go. It's currently 4:10 here. And you can go ahead and click on this and you'll see the clip gets loaded up. It's supposed to be 60 seconds long, but because of the keyframes in the FLV video, it turns out usually it ends up being about minute 10, whatever. And I still need to figure out how to, the video player is kind of wonky, whatever. That's not the point of it. The point of this was just making sure I could clip a video from an active stream and it be the last 60 seconds. So I think the next step of this whole project is to take this big red button here and to do the hardware side of this. So I am going to take some measurements and I need to make a case for this so that way I can actually have it be mounted. And we'll probably end up using a Pi Pico W in this for the controls. But yeah, I guess next up, let's first make a box for this to sit in and to actually be usable. So I'm gonna do this up in OpenSCAD real quick, and I might do a little time lapse, but we'll see. Alright, so the print is now finished. This is the lid of what will be the button. And if I grab it off here, I'll actually leave it there because there's actually light in there. But hopefully if I take this and slot it down onto it and get the little hole things aligned, it should maybe sit. It's close. It may be a little small because the shrinkage and just the fineness of the print, but I think it's close enough to where I can kind of get it if I force it a bit here. Yep, there we go. So if it's just barely, if I print this again, which I probably do because this is a quick one, see the print, it's not bad quality, but if I do it again, I'll probably have to make the hole just a bit bigger. But there we go. That's the head of the lid of this box. I can print the box out now next if I want to. But yeah, little proof of concept. And here we go, prototype is complete-ish. You can see the big red button here on the front in this nice large-ish case. Prototypes. Top is held with 2 screws here. I'll show you the internals in a second. But if we go ahead and switch over to the web panel here, you'll see that there is a new page here that shows clips basically of a channel. And if I go ahead and press the button and then reload the page, maybe give it a second. I should test this before. All right, my bad. I was looking at the local version of this, not the one that's actually running, that's like doing all stuff. Anyways, you can see here, November 28th, 402, this is the clip I just created a few minutes ago. And now I can go ahead and go into it and actually view the clip that's been created by this button here. And pretty cool deal. I also kind of fixed some stuff up. You can now sync on these videos properly. I also did some cleanup on the pages here too to make things a little bit interesting. You can see your stream key, delete channel, kind of all that. So a little bit of cleanup there. But like I said, this is pretty simple. It's just this button here, and let me go ahead and take the screws off and show you the internals. And this is the internals here. It's the button, Raspberry Pi Pico, and a battery bank, because there's not a way to plug this into anything yet through the case. I just put it in there. So yeah, that's really it. The Pico is just simply hooked up to the button to give the light power, but also receive the input from the switch. And then when the button's clicked, it just sends a post request to this to create a clip. So that's really all it is. It's not too difficult. Just had some leftover wire, and yeah, that's really all this is for the proof of concept of the prototype here, I guess. Next step is related to kind of deploy it, but there's no further testing or deploying to do yet. So that's the end of this project for, or at least this part of the project for now. So yeah, hope you guys have enjoyed, and hopefully you found this at least interesting, and I'll catch you guys in the next one. Peace out.